The second part of your lab experiment, you will be doing a chemical reaction in the water, and you'll see heat will either be released or absorbed. In this case, it looks like released, and the temperature of the water will change. Based on the temperature of the water change, you can calculate something about the chemical reaction. So we need to introduce you to a new term, and that's enthalpy. Enthalpy is stored heat. It's not hot. It's stored in a chemical form. So something like gasoline, say, has a high enthalpy, stored heat. When you burn it, that stored heat is released and you get heat given off. But anyway, so enthalpy is heat stored in the substances. It always refers to the substances. This term, delta H for the reaction, is the change in the enthalpy of the substances, the change in the heat stored by substances. It's the same as the Q for the reaction, energy that is given off or absorbed by the reaction. If we assume that all the heat that is released goes into thermal energy transfer and not into pressure and volume changes. And I just have to kind of technically tell you we're making this assumption that no work is being done, that pressure and volume are remaining constant, which is a pretty good assumption if there's no gases. So anyway, we are going to treat change in enthalpy for the reaction. This is also called the heat of the reaction. It will be the same thing as Q for the reaction for us. This is delta H for the reaction. Again, it refers to the substances. When that is a negative number, it means that heat is being released. And that occurs for an exothermic reaction. Exothermic heat is released, so the change in enthalpy of the substances is negative. They're losing heat. And of course, the opposite is true. If the change in enthalpy is positive, or the heat of the reaction is positive, energy is absorbed, and the reaction is endothermic. Okay, so we'll do similar calculations, actually a little shorter. When you do your chemical reaction, you'll watch the change of the water, and then you can figure out what kind of Q the water had, if it was gaining heat or losing heat. And so we will use that to say something about the heat of the reaction. So because we're saying that just like up here, we said all of the heat released by the substances goes to heat of the reaction and not to work, that allows us to say that the heat of the reaction, delta H reaction, is equal to the same number as the Q of the water, but the opposite sign. So this is kind of like we did in the last one. You take the same number, change the sign, and it tells you what the reaction did. We'll observe the temperature change in the water, calculate the Q for the water with SM delta T. Once we get that number, we'll change the sign, and that's the heat of the reaction. After that point, you'll have to, in lab, you'll have to change the units some, but that's not a big deal.